We are looking at arithmetic progression in this video. Now, what is an arithmetic progression, or AP for short? An arithmetic progression, AP, is a sequence in which the consecutive terms increase or decrease by adding or subtracting a constant. This constant is known as the common difference. Take note, this constant is known as the common difference. Common difference can be found by subtracting the first term from the second term or the second term from the third term, etc. For example, in the sequence 1, 5, 9, 13, the common difference is 5 minus 1, which is the first term. You subtract the first term from the second term, you get 4. Or if you subtract the second term from the third term, that's 9 minus 5, you have 4. And then if you subtract the third term from the fourth term, which is 13 minus 9, you also have 4. This tells us that 4 was added. 4 is the number that was being added to the preceding term to get the other term. So the 4, which is common, which is this is a difference. 9 minus 5 is a difference. 13 minus 9 is a difference. 5 minus 4 is also a difference. In mathematics, difference means subtraction. So when you subtract the first term from the second term and you keep on having a consistent a number, which the difference is consistent, when you repeat that same subtraction with the second term from the third term and the third term from the fourth term, or the fourth term from the fifth term, and you discover that the difference is consistent, is constant, that progression, that sequence is known as arithmetic progression. And arithmetic progression is one that is gotten when the consecutive terms increase or decrease by adding or subtracting a constant, and that constant is known as the common difference. So the difference is common when the first one is subtracted from the second term, or when the second term is subtracted from the third term, or when the third term is subtracted from the fourth term. So as we can see here, when you take the difference between the first and the second term, the difference is 4. When you also carry out the difference between the second and the third term, the difference is 4. When you carry out the difference between the third and the fourth term, the difference is 4. You can see that 4, 4, 4 is common between each difference that was calculated. So we call it the common difference, and this is only possible in arithmetic progression. So let's go on. The general form of an arithmetic progression is A is our first term, A plus D, A plus 2D, A plus 3D, A plus 4D, and on and on, where A is the first term and D is the common difference. The nth term of an AP. The terms of an AP are formed as follows. And first term is equal to A, second term A plus D, third term A plus 2D, fourth term is A plus 3D. Nth term of an arithmetic progression is equal to A plus N minus 1D. A plus N minus 1D. So notice something that you need to take note of. Note that the coefficient of D is always 1 less than the number of the term. So if you look at it, the first term is A, then second term is A plus D. The coefficient here is 1. Here, the first term, the coefficient of D is 0. So 0 times D will be 0. That's why you have only A here. Now for the second term, T2, so the second term, the coefficient of D is 1. Third term, coefficient of D is 2. So you see that it's always 1 less than the number of the term. So our nth term is equal to A plus N minus 1. So whatever N stands for the number of term in consideration. So if you are looking for the 25th term, N here stands for 25. N, like fourth term, N here is 4. Third term, N here is 3. So the nth term is that nth term is equal to A plus N minus 1. So it will always be 1 less than the number of the term. So if N here is not 25, or if for the nth term is 25, that is N here will be 25, then here will now be 25 minus 1, which is 24. So discover that it will now be A plus 24D. So the coefficient of D will be 1 less than the number of the term, which is 25 here. If it is 30, then this will be 30th term, and here will now be 29, because it will be 30 minus 1, which is 29D. So that's what this part is saying. So note that the coefficient of D is always 1 less than the number of the term. For example, when the term is 12, the coefficient of D is 11. So if you put it here, 12 minus 1 will be 11. So 11 times D will be 11D. And then you put your first term A. You solve and get your answer. Thus, the 12th term is A plus 11D. Similarly, the 25th term is equal to A plus 24D. The reason is that if you put it in this formula, the nth term, n here will not be 25 because we're looking for the 25th term. So n stands for the number of the term you're looking for, which is 25th. So A plus 25 minus 1, which will now give you 24 times t to give us 24t. The nth term may be denoted by either un or tn. So these are the two arbitrary symbols used for denoting the nth term of an arithmetic progression. So either you use un or Tn. So if you are using un, it's equal to a plus n minus 1 d, or if you are using Tn or Tn, is equal to a plus n minus 1 d. Same thing. So either use this or this. So let's take examples. So number 1 says find the 40th term of the linear sequence 6, 11, 16, 21. So in any linear sequence, the first term and the common difference are important. So always get your first term and your common difference. So let's start. So what we have, let's write this term out: 6, 11, 16, 21. Okay. So here our first term is the first number. So A is equal to 6. Our common difference D is equal to 11 minus 6 is equal to 5. 16 minus 11, 5. 21 minus 16 is equal to 5. So our common difference is 5. And now we have to look for the 40th term. So T40, Tn, the nth term is equal to A plus n minus 1 D. So where n is 40, T40, we're going to have A. Our first term A is equal to 6 plus 40 minus 1. And common difference is 5. So that will give us 6 plus 40 minus 1 is 39. 39 times 5. 9 times 5 is 40. 5 times 2 is 15. 15 plus 4, 19. 119. That's equal to 196. So the 40th term of this sequence is 196. Sure. The fourth term of an arithmetic progression is 15. And the ninth term is 35. Find the 15th term. So this particular case, we're not giving the first term, and we're not giving the common difference. So we're going to solve to get the first term and the common difference, and this will lead us to either using solving it simultaneously or subtract. So the fourth term, we're giving the fourth term. So T4 is equal to what? T4 is what? T4 is A plus 3D from our general formula. We're told that T4 is the fourth term of our arithmetic progression is 15. So T4 is equal to 15. So A plus 3D is equal to 15. Because equation 1. Then next one is that the ninth term is 35. So A plus 8D. A plus 8D will give us the ninth term. That will give us what? 35. Equation 2. How do I got 8D and 3D? So T4 will give us A plus 4 minus 1 to D. 4 minus 1 will give us A plus 3. 4 minus 1 is 2 times D. Give us the same way. T8 is equal to A plus the 8 here. You know, Tn, from our general formula, Tn is A plus n minus 1. So n is the number of the term we are considering. So when we talk about 8 term, 8 here, 8 is the n here. So, and you also have n in this part of the formula. So what you do is that T8 will be 8 minus 1 multiplied by D. So you have 8 plus 8 minus 1 is 7. 7 times D, 7. So that was what the note on the explanation I gave at the beginning of this video was talking about, that the number of the coefficients of D is usually 1 less than the number of the term. So if it is T8, the coefficient of D will be 1 less than the number of the term, which is 8. So 8 minus 1 will give us 7. So it will be 7. If it's T10, there will be A plus 9D. 11 should be A plus 10D. So take note of that. Now we have two equations here. So we can subtract the first subtract. Either we could say either we solve simultaneously and just put minus and eliminate A and solve, or we can write it in sentence, subtract equation 1 from equation 2, and that's simply solving simultaneously by subtraction. A minus A will give us 0. Now 3D minus 8D will give us minus 5D. 15 minus 35 will give us, let me say, 35 minus 15, 0, 2. So this gives us minus 20. So D is equal to minus 20 over minus 5. The minus cancel, minus 5 here 1, 5 here 4. So D is equal to 4. So our common difference is 4. Now we need to get the value of A, the first term. So we can put the value of D in any of these equations. So substituting 4 for D in equation 1. You can use any of the equation, but I want to use equation 1. In equation 1, we want to have A plus 3, D is 4, is equal to 15, and A plus 12 is equal to 15. So A is equal to 15 minus 12. A is equal to 3. So the first term is 3, and the common difference is 4. But the question says that we should find the 15th term. So therefore, T15. So remember that when in the general formula Tn is equal to A plus n minus D. So n is now the term we are considering, the number of the term we are considering. So now we want to look for the 15th term. So where we have n, we're going to put 15 there. That tells us that we are going to use this formula to generate the 15th term. So T15 is equal to A plus 15 minus 1, 15 minus 1 D. And this will give us our A is 3, the first term, plus 15 minus 1 is 14. 14. Common difference is 4. So 14 times 4, what is it? 14 times 4. 4 times 4 is 16. Carry 1. 4 times 1, 4 plus 1, 5, 56. So that will give us 3 plus 56, and that is 59. So the 15th term is 59. Okay, say therefore the 15th term is 59. Number 3. Your sequence is 8x, y, z, 20. So this particular case, our first term is 8. A is equal to 8, and then our common difference is unknown because there's no way we can remove 8 from x, and there's no way we can remove y from x to get the exact value for the common difference. The common difference is unknown, so but that is not a problem. There's a way we can get the common difference. So how we do that is that we know the number of terms here because the sequence here has only 5 numbers: 1, 2, 3, 4, 5. So we have T1, T2, T3, T4, T5. Since we know the value of T5, we're going to say T5 is equal to A plus 4D. So from here we can get, since we know our first term A, we can get our common difference from here. So D is equal to T5 is 20. The 5th term T5 is 20, and the value is known. So we say A plus, so A is equal to 8, which is the first term. 8 plus 4D is equal to 20. So 4D is equal to 20 minus 8, and 4D is equal to 12. So D is equal to 12 over 4. So 4 here 1, 4 here 3. So D is equal to 3. Now, since we know the value of D to be 3, common difference, X is the second term. So T2 is equal to A plus D. That's equal to A first term plus common difference 3. That's equal to 11. T3, okay, let me put here, is equal to X. So T2 is equal to X. Then T3 is equal to Y, and that's equal to A plus 2D. And that will give us 8 plus 2 times 3. So 8 plus 2 times 3 is 6. 8 plus 6 is 14. T4 is equal to C, and that's equal to A plus 3d. A is equal to 8 plus 3 times d. Our common difference is 3, and that is 8 plus 3 times 3 is 9, and that's equal to 17. So the sequence is the first term is 8, and x, which is the second term, t2 11, and then y, which is the third term, is 14, z, which is the fourth term, is 17, and then 20. So this is the sequence. Number 4, find the value of x given that x plus 1, 2x, and 2x plus 3 are consecutive terms of a linear sequence. So if this sequence is, or if this is a linear sequence, which means arithmetic progression, means that they must have a common difference. So from the principle of common difference, of course, the question said we should look for x. We didn't say we should look for fifth term or sixth term or whatever. The question wants us to get the value of x. So what do? We apply the principle of common difference. From the principle of common difference in arithmetic progression in A.P, that says that second term t2 minus t1 is equal to t3 minus t2. So which means that the common difference will be the same if you remove the first term from the second term or the second term from the third term. So here our t2 is 2x minus first t1 is first term, x plus 1. That will be equal to t3 is 2x plus 3 minus t2 is 2x. So let's solve. It's 2x minus x plus 1 will give us minus 1, and then 2x plus 2x minus 2x plus 3. So 2x minus x will give us x minus 1 is equal to 2x plus 2x minus 2x will be 0 to cancel out. Here will be 3, and x is equal to 3. So we'll move to this side to become plus 1, and x is equal to 4. So the value of x in this sequence is 4. Number 5. Now find the 10th, find the 10th, 15th, 100th, the nth term of the AP. Let's get our AP 5, 10, 15, 20. So in this AP, the first term is 5, and the second term is 10, 15, the third term is 15, the fourth term is 20. So we have to look for a 10th term. So let's get our general formula. Tn is equal to a plus n minus 1 d. I'm going to make use of this part. Let me draw it like this. Okay. So now I'm going to A says we should look for the 10th term, C10. So C10, our A is the first term, which is 5 plus, now the 10 is 10 minus 1. N is the number of 10 we are considering, which is the 10th term. And the common difference is 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5. So our common difference is 5. And this will give us 5 plus 10 minus 1 is 9. 9 times 5. That's equal to 5 plus 45, and that will give us 15. So the 10th term is 15. B. This is 15th term. So T15 is equal to 5, which is the first term. 15 minus 1 times 5. That's 5 plus 15 minus 1 is 14 times 5. That's 5 plus 14 times 5. 70. And that will give us 75. C. 100th term. C100 is equal to 5 plus 100 minus 1 times 5, which is the common difference. That will give us 5 plus 99 times 5. 5 plus 495. That's equal to 500. So the 100th term is 500. And then the nth term, the Tn is equal to A plus n minus 1 d. And this will give us our A here. The first term is 5 plus n minus 1. Of course, we are looking for the nth term, no value. We are looking for the nth value, nth term. So here we have n. Whenever you subtract, our common difference is 5. This is 5 plus n times 5 will give us 5n. Minus 1 times 5 will give us minus 5. So 5 minus 5 plus 5n. Plus 5 minus 5 will cancel out to give us 0. So the nth term is 5n. That's the nth term, 5n. One. What is the 23rd term of the arithmetic progression? Minus 7, minus 3, and 1. So 23rd is C, 23. Our first term is minus 7. Okay. Let's see, n is equal to E plus n minus 1 d. So T 22 is equal to first term minus 7 plus common difference is minus 3. Common difference T is equal to minus 3 minus 7 minus 3 plus 7, that's equal to 4. So 22 divided by 23 minus 1 times 4 minus 7 plus 22 times 4. Now minus 7 plus 20 times 4 will give us 88. So minus 7 plus 88. 81. So the 23rd term is 81. Let's find the number of terms in an arithmetic progression AP. So we have 2 minus 9 minus 20 all the way to minus 141. So minus 141 is the last term, but we don't know exactly how many numbers of terms there are in this sequence. So we have to look for the number of terms. So since this is the last term, T141, Tn will give us for the last term of C141, Cn will give us the last term, Cn, which is what we are looking for, is equal to the number of terms. Is we don't know the number of terms, how many they are, but we know that the last value is Tn. So Tn, so I'm going to say minus 141. What it means is that the number of terms in this sequence, that if it's 25, if there are 25 numbers that make up the sequence, the 25th term is minus 141. But we only know the value, but we don't know how many there are, because there are 3 dots here before this last term. So we want to know how many there are. So for us to get that number, this will give us the first term E plus n minus 1 times common difference. Our common difference will be minus 9 minus 2, which is equal to minus 11. So minus 141 is equal to E plus, A is minus 2, A is 2, 2 plus minus 11 times n will give us 2 minus 11 n, minus 1 times minus 11 plus 11. So minus 141 is equal to 2 plus 11 minus 11n. Minus 141 is equal to 2 plus 11 gives us 13 minus 11n. So this will come here, 11n is equal to 13 plus 141. So 11n is equal to 141 plus 13, 154. So n is equal to 154 divided by 11. N is equal to 14. So there are 14 terms that make up this sequence. 14 terms. Number 3. The 12th term of an AP is minus 41. If the first term is 3, find the 20th term. So the 12th term, C12 is equal to A plus 11D. We're told that if the first term, so T12 is T12 is equal to minus 41. For A is equal to 3. But we're not told what the common difference is, so we're going to look for the common difference first. So using T12 A plus 11D, but T12 is minus 41, so minus 41. The 12th term is minus 41, so we put it in place of T12. A is 3 plus 12 minus 1, and the common difference D, which is what we are looking for. Minus 41 is equal to 3 plus 11D. So minus 41 minus 3 is equal to 11D. So 11D is equal to minus 44. So D is equal to minus 44 over 11. 11 here 1, 11 here 4. That's equal to minus 4. So our common difference is minus 4. So now we can look for the 20th term. C20 is equal to A plus 19D. Starting from A plus C20 is equal to A plus 20 minus 1. Which is the 20 minus 1 is equal to 19. 19 times D will give us 19B. A, which is our first term, is 3 plus 19. 19 times minus 4. So 19 times minus 4, that gives 3 times minus 3 plus 19 times minus 4 will give us 2 times minus 76. So plus times minus will give us minus 3 minus 76. 3 minus 76, and that gives us minus 72. So the 20th term is minus 72. Number 4. Find the common difference in an arithmetic progression given that their first and 28th terms are minus 14 and minus 5 respectively. So we have to look for the common difference. The 28th term, the first term is equal to, given that the first term is minus 14, and then C28 is equal to 28th term is equal to minus 5. And then we have to look for the common difference. So T28 is equal to A plus 27D. A is minus 14, C28, the 28th term is minus 5. So put minus 5 is equal to A minus 14 plus 27D. And we're looking for the common difference. So 27D is equal to minus 5 plus 14. So 27D is equal to minus 5 plus 14. That will give us 14 minus 5, 9. So D is equal to 9 over 27. 9 here 1, 9 here 3. Therefore, our common difference D is equal to 1 over 3. Number 5. The 12th term of an AP is 32. If the first term is 1 over 2, what is its common difference? So, first term, A is equal to, if its first term is equal to 1 over 2, then T12 is equal to 32. So we need to look for the common difference. T12 is equal to A plus 11D, and T12 is 32. So 32 is equal to A 1 over 2 plus 11D. 2 times 1, 2 plus 1, 3, that's 32. 3 over 2 plus 11. D. We bring this to this side. 11. D is equal to 32 minus 3 over 2. 11 D is equal to LCM is 2. 2 into 1 is 2. 2 times 32. 64 minus 3. So 11 D is equal to 64 minus 3, which is 61 over 2. Here to the over 1, then you cross multiply. Cross multiplying. Cross multiplying 11 D. Okay, 2 multiplied by 11 D will give us 61. 22 D is equal to 61. D is equal to 61 over 22. So 61 divided by 22 will give us 2.772. The question says we should correct our answer to one decimal place. So D is approximately 2.8. So a decimal place. Well, the first term of an arithmetic progression is 8. If the 10th term is double the second term, so first term A is equal to 8. So if the 10th term is double the second term, T10 is equal to 2 times this T2, which is equal to 2A plus D. That equals 2A plus 2D. So that's the 10th term. Find the common difference. So T10, which is 2A plus 2B, and we know that T10 is equal to A plus 9D. But T10 is equal to 2A plus 2D, which is 2 times the second term. So 2A plus 2D is equal to A plus 9D. So collect like terms. 2A, bring A to this side, A, 9D minus 2D. So A is equal to 9D minus 7D, which is equal to 7D. And the first term A is equal to 8, 7D. So D is equal to 8 over 7. Number 2. The second, third, and fourth terms of an AP are x minus 2, 5, and x plus 2. Respectively, calculate the value of x. So we can only get the value of x by applying the principle of common difference in AP. Since we are not to look for first term or second term or whatever, let me say applying the principle of common difference in an AP. So since the question says is the second, third, and fourth, that means T3 minus T2 is equal to T4 minus T3. So T3 is 5 minus T2, which is x minus 2. 5 minus x minus 2. T4, x plus 2 minus 5. Minus times x plus minus x. Minus times minus 2 plus 2. X plus 2 minus 5 gives us minus 3. So 5 plus 2 gives us 7 minus x. X minus 3, correct like sense. 7 plus 3 plus x plus x. X plus x is 2x. And 7 plus 3 is 10. So x is equal to 10 over 2. 2 here, 1, 2 here. 5. Therefore, x is equal to 5. X equal to 5. Number 3. If 1 over 2, 1 over x, 1 over 3 are successive terms of an arithmetic progression AP, show that 2 minus x over x minus 2 is equal to 2 over 3. 1 over 2, 1 over x, 1 over 3. So how we can How we're going to show that 2 minus x over x minus 2 is equal to 2 over 3 is from applying the principle of common difference. Applying the principle of common difference. And EP T2 minus T1 equal to T3 minus T2. So T2 is 1 over x. 1 over x minus 1 over 2 is equal to 1 over 3 minus 1 over x. So let's simplify this part. LCM is 2x. 2x divided by x is 2. 2 times 1 is 2. 2x divided by 2 is x. X times 1 is 1. Or x times minus 1 is equal to minus x. Here LCM is 3x. 3x divided by 2 is x. X times 1 is x. Minus 3x divided by x is 3. 3 times 1 3. Now the next thing is to, since we want to show that 2 minus x divided by x minus 2 is equal to 2 over 3, we're going to multiply both sides by 3x. Multiply both sides by 2x. So this is given 2x. 2 minus x over 2x is equal to x minus 3. 3x over 3x. So this will cancel. To cancel, this will give me 2x. 2 minus x over 2x is equal to x minus 3. So next, I'm going to divide both sides by 2 minus x. Divide both sides by 2 minus x. So 3x 2 minus x over 2x 2 minus x is equal to x minus 3 2 minus x. This will cancel here 1, this will cancel here 1. So we have here 3x over 2x is equal to x minus 3 over 2 minus x. So here x cancel x, we have 3 over 2 is equal to x minus 3 over 2 minus x. But the question says we should show that 2 minus x over x minus 3 is equal to 2 over 3. So here 2 minus x is our numerator, but here x minus 3 is our numerator. And on this side 2 is our numerator, but here 3 is our numerator. So what do we do? We're going to invert it. So to do that, we're going to take the reciprocal of both sides. Take the reciprocal of both sides. So what that implies is that we're going to change, so this becomes 2 over 3 is equal to 2 minus x over x minus 2. So that's our answer. Number 4. If it's x, y, z and 32 is an AP, find the value of x, y, and z. So here A is equal to 32 and 1, 2, 3, 4, 5. T5 is equal to A is equal to 8, T5 is equal to 32. So we cannot get the common difference because we don't know the value of x. So what we do is that since we know the fifth term, we are going to get the common difference from the fifth term. So T5 is equal to A plus 4D. And T5 is equal to 32. So A plus 4D is equal to 32. Where A is equal to 8. 8 plus 4D is equal to 32. So 4D is equal to 32 minus 8. 4D is equal to 32 minus 8. 32, 8, 12 plus 4, 24. 24. So D is equal to 24 over 4. 4 here 1, 4 here 6. So D is equal to 6. Now that we've gotten D, T2 is equal to x, that's equal to A plus D. So A is equal to 8 and D is equal to 6. So 8 plus 6 is 14. T3 is equal to y, that's equal to A plus 2D. 8 plus 2 times 6, that's 8 plus 12, that's 20. T4 is equal to Z, that's equal to A plus 3D. And that will give us A is equal to 8 plus 3 times 6, 8 plus 18, and that's 26. 26. Therefore, the terms are 8, 8, 14, 14, 20, 26, and 32. Number 1, if 2, A, B, C, D, 32, or 22 are terms of an AP, find BD minus AC. So here A is equal to 2, common difference to known 1, 2, 3, 4, 5, 6, C, 6 is equal to 22. So we're going to get our common difference from using T6. So T6 is equal to A plus 5D. But T6 is 6 times 22. So 22 is equal to A, which is 2 plus 5D. So 5D is equal to 22 minus 2. 5D is equal to 20. D is equal to 20 over 5, 5 over 1, 5 over 4. So D is equal to 4. So T1, so T2 rather, is equal to A, that's equal to A plus D. A is 2, common difference is 4, that's equal to 6. T2 is equal to B, that's A plus 2D. A is 2 plus 2 times 4, 2 plus 8, and that's equal to 10. T3 is equal to C, that T4 is equal to C, A plus 2D, 2 plus 3 times 4, that's 2 plus 12, 2 plus 12 is equal to 14. T5 is equal to D, that is equal to 2 plus 4D, 2 plus 4 times 4, 2 plus 16, 18. So therefore the terms are 2, A is 6, B is 10, C is 14, and D is 18, and then 22. So the question says, this is A, B, C, D. The question says we should look for, therefore BD should find the value of BD minus AC. BD minus AC is equal to B is 10, 10 times BD, 10 times 18 minus BC, AC minus AC. A is 6 and C is 14. So 10 times 18 is 180 minus 14 times 6, 84. And so 180 minus 64, 96. Number 2. The first term of an arithmetic progression AP is minus 8. A is equal to minus 8. If the ratio of the 7th term to the 9th term is 5 to 8, so the ratio of T7 over T7 to T9 is equal to 5 ratio 8. Find the common difference. So let's put T7 over T9 is equal to 5 over 8. This implies that T7E plus 6D over E plus 8D is equal to 5 over 8. So let's cross multiply. So come here and say A plus 6D over A plus 8d divided over 8, cross multiplying, we're going to have 8 plus 6d is equal to 5a plus 8d. 8 times a gives 8a. 8 times 6, 48d. 5 times a, 5a. 5 times 8, 40d. Collect like terms. Collect like terms. 8a, so cross over to become minus, and 40d minus 48d. 8a minus 5a is 3a. 40d minus 8d will give us minus 8d. Now, a, what is the value of a? From what we given, a is minus 8. So, but a is equal to minus 8. So, 3 minus 8 is equal to minus 8d. 3 minus 8 is minus 24 minus 8d. So, d is equal to minus 24 over minus 8. Minus will cancel minus 8 here, 1, 8 here, 3. Therefore, d is equal to 3. The common difference is 3. Number 3. If minus 8x, y, 19 are a sequence in arithmetic progression, find the value of x and y. Minus 8x, y, 19. So here we cannot get the common difference because we have x is not known, y is not known. So if we were to get the common difference, it would be the difference between the second term and the first term, or the third term and second term, or the fourth term and third term. But we don't know the second term, we don't know the third term, so it cannot work. So we go this means, or we follow this procedure. A is equal to minus 8, and then t1, 2, 3, 4, t4 is equal to 19. So we need to get a common difference from t4 since we know the first term. So t4 is equal to a plus 3d, where t4 is 19. So a plus 3d is equal to 19. So but a is equal to minus 8. So minus 8 plus 3d is equal to 19. 3d is equal to 19 plus 8. And 3d is equal to 27. And d is equal to 27 divided by 3. 3, 1, 3, 9. So d is equal to 9. So now we can get x. So t2, which is the second term, is equal to x, and that's a plus d. A is minus 8 plus 9, and that's equal to 1. T3 is equal to y, that's equal to a plus 2d. A is minus 8 plus 2 times 9, minus 8 plus 18, and that's equal to 10. So therefore, the terms are minus 8, 1, 10, and 19, where 1 is x and 10 is y. So we can say, therefore, x is equal to 1, y is equal to 10. Well, this would make it look like a quadratic equation. So I can say the values of therefore the values of x and y are 1 and 10. 1 and 10. Number 4. The numbers 11, P, Q, 21 and half form an arithmetic progression AP. Find the value of P and Q. 11, P, Q, 21. So just as this case, our first term is equal to 11, and then T4 is equal to 21 over 2. There's no way we can get the common difference because P, which is the second term, is not known, and also Q. So if you subtract 11 from P, that does not give you a common difference. And same way if you subtract 21 from Q, that will not give you a common difference. So the best way to get common difference is to get it from the fourth term, which we know, which is 21 over 2. So T4 is equal to A plus 2D. Note T4 to be 21 over 1 over 2. A plus 2B is equal to 21 over 2. A but what A but A is equal to 11. So 11 plus 2B is equal to 2 times 21, 42 plus 1, 43 over 2. So 11 plus 2B is equal to 42, 43 over 43 over 2. So bring this to this side. 3D is equal to 42 over 2 minus 11 over 1. 3D is equal to 2 into 2, 1. 1 times 43. 43, 2 into 1 is 2. 2 times 11, 22. So 3D is equal to 43 minus 22. 43 minus 22. 3 minus 2, 1. 4 minus 2 is 2. 21 over 2. Cross multiply. Cross multiply. We're going to have 3D 2 times 3D is equal to 21. 6B is equal to 21 and D is equal to 21 over 6. So 3 here, 7, 3 here, 2. So D is equal to 7 over 2. Now that we know that common difference, T, which is T1, T2 is equal to P, and that's equal to A plus D. So A is 11 and D is 7 over 2. LCM is 2. 2 into 1 is 2. 2 times 11, 22 plus 2 into 2 is 1. 1 times 7, 7. That's equal to 29 over 2. T2, let me cancel. T3 is equal to A. T3 is equal to Q. That's equal to A plus 2D. A is 11 plus 2 times 7 over 2. 2 here 1, 2 here 1. That's 11 plus 7. That's equal to 18. So we say therefore the terms are 11, 29 over 2, 18, and then 21 over 2. So therefore the values of P and Q are P is equal to 29 over 2, Q is equal to 18. Q is equal to 18.